All right, exercise 4F. This is exercise 4F to do with area of a sector. So first thing is you need to know what a sector is, what a segment is, what is a chord. So we're going to identify the things that we already know. Okay, so we've got a circle. The purple rim that you currently see is my circle. What is the name given when you're saying the distance around a full circle? What is the name again? Can I please have, let's go Rihanna. What's the name given when we talk about the distance around a circle? Circumference, very good. So I want you to fill in, this is the circumference in purple. Let's find another person. Let's go to the back row now. Let's go with, yes, James. James, what is this section, this red line, what is this representing?
The radius.
The radius, very good. We have the radius, which is from the center of the circle. That's how we know, from the center of the circle to any edge of the circle. This is only halfway through the circle, is called your radius, right? Then what is that green line that essentially goes from edge to edge, but also goes through the center onto the left side of the room? Now let's go with Eloise. What is the green segment here called when you go from one side to the other side? Diameter. It is the diameter. Very good. So this is called your diameter. Okay. So this is your diameter. Those are the three things that you're more familiar with at the moment, right? Now, there are some new terms. You don't need to know them all. Next year, you will learn them all. But at this moment, I'm going to give you a couple of names to get you a bit more familiar with them. Because today, we're learning what we call sectors. Now, let's have a look at a sector. What is a sector? Notice the shaded region here, which actually I should do it in highlight. I'm going to highlight in yellow so you can see. This section here is what we call a sector. But I want you to compare this. How is it different to a segment? Can anyone spot the difference? What's the difference between the yellow region and the blue region right now? Can anyone see? Oh, yes. Now, there's this triangular part, and they have a key idea about this triangle. Because there's something I'm looking at it, and there's something I'm looking for that tells me this is going to be a sector, and something that's going to be a segment. It has. And the R is always connected to what? The radius always has to connect to what? What is the difference? We're almost there. You're right. They both have a radius, so they have an R from here to here, but they're all connected to something. There's a property of R. Why is this not an R? Or why is this not an R? Why is this not an R? Why can't I say this is an R and this is an R as well? Very good. So one of the key things, notice the difference between the blue and the yellow. The key difference is one is not connected to the center and one is. Okay, so a segment is also an area that is part of the circle, but a sector specifically has to connect to the center of the circle. Okay, so a sector can be as big or as small as you want it to be. I can do this as a sector as an example. I can say that this, if I connect to the center, and then I connect out from the center, and then I colored this entire region together, this is a sector. See that? That's a sector because it goes right to the center. But what is not a sector? When you draw an area that doesn't cross through the center, so it doesn't connect to the center. So this is a segment. Okay, so right there, that's a segment. That's an area of the circle, but we call that a segment. So to identify the difference between the two, a sector has to have the radius. Okay? A segment does have a line. So I'm going to draw the line. This line here, there is a name for it that we call, and you'll practice it next year where you learn theorems for this. Does anyone have a hunch of what this is called? Good, I'm teaching you something. It's called a chord. Okay? Very good. So that diagram there, they're trying to teach you that this is called a chord. See, it doesn't cross through the center. Okay, it doesn't touch the center. That is a chord. You can make many chords as you want, but as long as they don't cross the center, it is a chord, not a diameter and not a radius. Michael.
Does it matter how big a segment is, or does it be as big or as small as possible?
Well, usually if you can make this a segment. You can call this entire thing a segment if you want to. You could. You would call it, there's a specific name for the bigger area and smaller area. And I don't want to confuse you too much, but for those who are interested, the bigger area we call a major and the smaller area we call minor. Okay? But what I want you to learn today, because we're only learning sectors, you only needed to know how to identify a sector. So this is what you're interested in looking at. Okay? Just that section. So today, we're going to look at areas of a circle. Now, you learnt previously the area of a circle. Let's revise. Area of a circle. What was the formula for the area of a circle again? Let's go back to the right-hand side. Maddie. Very good. R squared times pi. We often say pi times r squared. Okay, this is the formula for the area of a circle. But remember, this is for a full circle. This is for the area of a full circle. So what happens when you don't have a full circle? Boys, listening? Thank you. Thank you. What happens when you don't have a full circle? So the problems that you've done so far, you've done half a circle. You've done a quarter of a circle, which is great. But what you haven't done, what if it wasn't a quarter? What if I gave you, instead of it being 180 degrees, which is half a circle, instead of it being 90 degrees, which is a quarter of a circle, what if I gave you 37 degrees? And I said, what is the area of that part of a circle? So when you're eating pizzas and they cut that, each pizza has to have a certain area. How do you work that out? Because we can do halves, we can do quarters. Why can't we do 37 degrees? If we can do 180 degrees and we can do 90 degrees, why can't we do 37? Of course we can. We have to think about the process here. How did you find, or how would you normally find area of half a circle? What's the technique that you would go through? Good. Okay, this is the key part. So we always have to question, why did we logically do it? So here we go. We said pi r squared gives me a full circle. But this is the key part. You said divide by 2. Why by 2? And how did you know? Okay, that's good. Now I'm going to rewrite that. So Blaise said it's because it's half of. Now of means what again? Times, add, subtract, divide. Which one is it? No, we often think it's divide, but of means times. So I'm going to write here. So this is where we're at right now. Half circle, you told me it's half times pi r squared. But what I'm even more interested in is, how are you 100% sure that that picture is definitely half, 1 out of 2? Because you can't just assume things. How do you mathematically, critically say, this is 100% sure there's 1 out of 2? Okay. 180 out of what? That makes it half. Very good. So I'm going to rewrite this. What you're actually doing, and we don't often think about it, you're actually doing this. You're taking the angle that you have, which I'm going to call theta. That's the symbol. That's what it looks like. Theta. You're taking the angle, so 180 degrees, out of the full circle. Now, full circle, we know that full revolution has how much in terms of angles? 360 degrees. So we know the total is 360, and we know that half a circle is 180 degrees. That's why 180 out of 360, you simplified that in your head automatically, instinctively, intuitively, that this was half. It's the same thing for the next one. How did you know that you're going to divide that by 4? You get pi r squared to full circle. Where'd the 4 come from? It is the same idea. It was 1/4, right? And you're still multiplying that to the full circle, pi r squared. But how'd you get a quarter? What's the logic? Where'd the quarter come from? 90 out of? Correct. So now if you see the pattern and you understand your logic of where you've come from, you now know this is 90 out of 360. That's where you got your quarter from. 90 is a quarter of 360. Then how would you do when you have 37 degrees? What's the logic here too? So pi r squared is a full circle. I don't want the full circle. I do have an angle, 37 degrees. How would I work it out?
Divided by 90 7 to 9, 7 to 9.
How'd you get that 9? What'd you do?
I get 60 divided by 3.
Oh, it's the other way around. So you took 360, you took the big circle and you divided. Its total is always out of 360. So it should be 90 divide 360, 180 divided by 360 because it's smaller than 1.
0.1037.
Very good. See, that makes more sense because if you're taking a portion of a circle, how could you be more than 1? If I got a pizza, it's 1 pizza. If I took a portion out of it, it's no longer 1 whole. It should be less than 1. So if you're getting an answer that's above 1, it doesn't make sense. It has to be 0.3, 0.5, 0.7, 80% of itself. It makes sense to be less than 1, and it doesn't make sense to be greater than 1. So that's what I mean to be critical in mathematics. When you get an answer, does it make sense with what you want to do? So in this case here, we know it should be 37 degrees out of 360. Type this in your calculator. Now, this whole exercise, you do need a calculator like someone over here who has a calculator, Logan. Very good. Okay, he's been practicing that. He's meant to do. Please have a physical calculator. Boys, thank you. Please have a physical calculator. I know that you can get it on your laptop, but the laptop is limited and there's flaws to it when you're typing. I want you to get a physical one. Okay, if you haven't got one, please get one. It is going to be your practice as you move through the years. You have to learn how to use a calculator for 11 and 12 for sure, for the exams. Okay? So, today's lesson, what have I taught you so far? You learned the area of pi r squared from our previous exercise. I'm only teaching you one extra part, is to realize how have you been doing half and a quarter, and I've broken it out logically for you. You're actually getting half or dividing it by 2 from actually getting 180 out of 360, 90 out of 360 for a quarter, and then when you're doing a section or a sector, 37 out of 360. That's the only thing that you're adding on. So if you're doing this on your Google calculator, how do you type a fraction? Sometimes they don't help you to type a fraction. What you actually would have to type is what you see. So it'll be 37 divide 360 times pi times whatever the radius is squared. Okay, now in terms of bud mass, which one do you have to do first?
37 divided by 3.
No. Which one do you have to do first? Who said R squared? Very good. Bud mass indices come first. So please, if you're doing this on your Google and you type this entire thing out, you're going to get it wrong. Because what they will think is they think that you're doing all of this and then square it. Okay? I want you to type this first. So if you're doing on the Google, if you're doing on the calculator, it should be fine. But if you're doing on a Google calculator, then I want you to do R squared first and then times pi times 37 divided by 360. Okay? Or you can do 37 divided by 360 times pi and then do this separately times the R squared separately. Otherwise, you can screw it up because the order does matter. Okay? So Google may not know. Your calculators generally know. So you should be able to type the fraction. You should be able to type times, pi, and R squared. And your calculator will follow bud mass. And it'll get it right. Okay? So if you don't have the handheld, just be careful if you're doing that on Google. Okay? So, today's lesson, that's literally it. You're only learning a couple of sentences from segment, sector, chord. Next year, that is something that you do. Year 10, they start looking at chord theorems. There are properties that you will need to know about chords, especially if you're doing specialist maths. Otherwise, that's all you need to know for today. So, sector, that's all we're adding on. Okay, so what is the sector? Links back to the center. It's part of the circle. Okay? All right, here we go. So what's an example? This is what I want you to have a go with. Okay, I'm going to give you, currently it's 10:41. Let's give you 4 minutes. Have a go 2 minutes each. Have a calculator. What is the radius? What is the angle? Find me the area of these two examples. Be careful with B. I often get students get it wrong for part B. Think before you do. Think before you do. So part B, part A should be straightforward. Part B, I want you to think a bit. You run right into it. That's the common mistake I often get when I do a test. Have a think. You've got 4 minutes with your calculator. Want you to work out what is the area of each sector. So they're all sectors because they're all connected to the center of a circle. I've written the formula for you. Paper? How do I know? How do I know? What am I looking at? How do I know that this is 2 and not the diameter? Correct. Because there's only, so you have to try to picture a full circle. So you have to imagine it. So if I imagined it, you see the 2 is only halfway. So if I pictured it, it's only halfway. Okay, so if you can picture it and it goes from edge to edge, that's a diameter, then you halve it. So in this case, the radius is 2. You're correct. Radius is 2. Two more minutes. 2 more minutes to get the answer for A and B. You've got the formula right there. B is think before you do. Very common mistake. Very common mistake.
What does it say about the over 360?
Oh, that's called theta. That means angle. So whatever angle your problem has. Yeah. Spelt like this. Theta. Let's do a nice circle and a loop. Theta.
What's the 2 centimeters?
Very good. This is your radius. But how?
Radius, I got it right.
And how I know is because I'm trying to imagine if this was a full circle, you can see that this would be the center. It's only coming out. Yeah?
Should we square it? Yes.
Very good. Very good. I'm glad it's easy. All right, team. I'm going to get my calculator up as well. Let's just see. And then we'll check our answers together. Calculator. All right, here we go. Let's see. What was your answer for A? Example 13A. Let's go with middle row. Listening. Shh, eyes and ears towards the board. Thank you. All right, middle row. Who have I chosen? I'm going to go with, let's go with Jack. Jack, what was your answer for A? Example 13, but A. 4.18. Let's see if we got this correct. If you got 4.18, I'm going to check if it's right. You give yourselves a tick. So here we go. The angle has to be 120 degrees of a full circle. So if I continue, that's a full circle. So it's 120 out of 360 times pi times now, what's the radius? I can see if that was a full circle, this length is the radius. So the radius has to be 2. So I've got 2 squared. Okay, so when I do this on my calculator, they should already know. So I'm going to type in control fraction 120. Whoops. Going back to this, 120. Oh, I can't even type it. Oh, numbers not working. Oh, why am I typing up there? Oh, why is that happening? Yeah, why is it going on the top left? Oh, hey, it's there. That is so weird. It's like I have to press enter. And then 360. Oh, this is so annoying. Two squared. Oh, wow. That's a bit weird. I need to check what's going on with my settings there. Anyways, yes. Jack, you are correct. It is 4.18879. But because the question asks you to correct 2 decimal places, I'm going to write it all out. It is 4.18879. Now, the first 2 digits is what you want, but you always have to check the next digit. If it's 5 or more, what do? Round up. So this means because this is 8, it's bigger than 5, you need to round this 18 to now 4.19. And I'm not done yet. What am I missing? What am I missing? Good, squared centimeters. All right, so I want units there. So you can see question, method, answer. Very quickly. All right, next person. B. Now B is trickier. Just a more detailed trickier. Area is theta over 360 times pi times the radius, which we already know is 5 squared. I'm interested in your angle. Hands up if you put your angle as 70. Hands up if you put 70 there. Good. Why is it 290 and not 70, Krish? Very good. This angle here, this 70 degrees is in the gap. You're trying to find the area of the circle, so you need to know what the angle is. The angle is not 70. The angle is this angle here. So, you know the full circle is 360. If you've already removed 70 of them, what's left over? So 3, very good. So this had to be 290. Therefore, you shouldn't be putting 70. It should have been 290 degrees, which makes more sense. It's more of a circle. 290 out of 360 makes more sense for that diagram there. Then if you do that correctly on your calculator, which I don't trust my digital one, I'm going to get my physical one. Let's check answers. Now going to the left side. What was your answer for this question? Let's go with Logan. What did you get?
I was in the middle of beginning it.
Okay, you got your calculator there? Yeah, type it in. Let's go. You and I race. There we go. I've got 290 divided by 360 times pi times 5 squared. I've got my answer. Have you got yours?
No, I tried to do the calculator. No, I tried to do the thing.
Okay. Well, that's why we want to practice. Okay, so you need to be working really fast. I'm actually really slow with it. My seniors are much faster than I am. We need to be faster at it. Okay? So fraction-wise, if you weren't sure how to do it, you can just do 290 divided by 360. It has to divide 360. Whatever that answer is, times pi, times, and then type 5 squared.
Oh, we doing the area thing inside?
Sorry?
We doing the area thing inside?
Of this one?
Yeah, that.
Yep, that's the one we're doing. We always do the inside. Yeah, it's part of the circle. Sector. All right. What'd you get, Logan? What's your answer?
63.26, 268, 268,185,388.
Very good. So we got the same answers here. If you got your answers 63.268185, that is correct. But you want to correct this to 2 decimal places. Correcting to 2 decimal places, what would this equal to going all the way back? Oh, it looks like Jake is ready. Jake, round this to 2 decimal places for me. What would it be? 63 point?
I don't know. 25.
Now, well, the first 2, so when I say 2 decimal places, okay, so I want to guide you through this, okay?
Yeah.
So for those who don't know as well, when they say correct to 2 decimal places, listening, Jake, listening, I'm explaining, yeah? When you're corrected to 2 decimal places, you pick 2 digits. So I've got 2 digits here, 26. But what do you have to check? You always have to check the next digit afterwards. That next digit, if it's 5 or more, you round this one up. If it's not, you leave it as it is. In this case, 8 is bigger than 5. That's why it's 27 or 27. Okay? So that's the answer, but what am I missing again? Very good. Squared meters. Okay? All right, I'm going to leave it there. That's today's lesson. That's what I want you to work with. So finding areas of a sector, that's how you do it. I'm only teaching you that extra section. How do you do it when it's not half, not a quarter? Can you do it when it's 31 degrees, 290 degrees? You should be able to do them. Okay? Questions are in OneNote. Please have a look. I believe it's 1, 2, 3, 4, 5, and 8. 1 to 5, and then 8. Okay, I'm going to